Welcome to SIIMcast, a podcast brought to you by the Society for Imaging Informatics in Medicine.
Greetings, SIIMcast listeners. Today I'm having the pleasure of sitting with Dr. Howard Chen. Dr. Howard Chen is a musculoskeletal radiologist at Cleveland Clinic, serving as the Vice Chair of AI for Radiology, Pathology, and Lab Medicine. From 2020 through 2023, he served as the Chief Informatics Officer for Imaging, leading an informatics team through 4 hospital mergers and acquisitions, orchestrating a PACS replacement effort for 300 radiologists across Ohio and Florida, and kickstarting radiology IT operations at Cleveland Clinic, London. After a ransomware attack disabled an affiliate hospital, he led an enterprise radiology cyber attack task force at Cleveland Clinic for operational recovery and building readiness policies and procedures for catastrophic IT downtime. He volunteers in leadership positions such as the chair for SIIM Security Subcommittee, as a member of the cybersecurity work group on the American College of Radiology Commission on Informatics, and as a chair for RSNA Informatics Policy Committee. Dr. Chen is a guest editor for JACR's upcoming security special issue and is leading the ACR SIIM Joint White Paper on Information Security. I cannot tell you how much I enjoyed chatting with Dr. Chen, and I hope you enjoy this episode as much as I did. Welcome, SIIMcast listeners. I've got the pleasure of sitting with Dr. Howard Chen, a very busy man who is always very graceful with his time. He's going to talk to us today about a number of cybersecurity-related topics. So this episode came about from a series of LinkedIn posts and conversations I've had with him where he's been talking about this thing called the NSA Codebreaker Challenge. So Howard, enlighten us. What is the NSA Codebreaker Challenge?
Oh, I'm so glad you asked. Happy to be here, Mahan, and thank you so much for inviting me. The NSA Codebreaker Challenge, well, it is a challenge put together by the National Security Agency. Now, they hold it every year. This previous year's challenge began September 16th and goes all the way through January 17th, and it is pretty typical. Multiple number of months, and think of it as like a mega hackathon challenge with multiple parts. This previous year's challenge, for instance, has 7 parts, and you must finish task 1 before you go to task 2, task 3. So it's mandatory, sequential. That's not always the case. On some previous year's challenges, you can have teams, you can do things in parallel, you can jump around. So depending on how it's structured, each year the challenge is different. Each year's challenge also has a story. There's a narrative behind it. And it's usually some sort of hot topic. Like a few years ago, the narrative is based on ransomware attacks on an organization. This past year in 2024, the challenge is about the persistent adversarial threats, so nation states and things like that.
Very cool. I've got a tangential question before we talk more about the NSA Codebreaker Challenge. So I've known you for many years. You're a radiologist by training. You've got a computer science background, obviously a lot of interest in informatics. But what drew you specifically to cybersecurity? I feel like that's a very near and dear to your heart topic.
It is. And there are, I'd say probably there's a personal reason and then there's a professional reason. The professional reason is that it has become very near and dear to the hearts of my organization after one of our hospitals actually was taken down by a ransomware attack. And that was kind of one of the first, that would happen in like around COVID. So there were multiple disasters happening all at the same time, incident response, and coordinating not only the recovery plan for that one hospital, but also how does everyone else, we have a network of multiple hospitals, all of it covered by our radiology program. How does everyone else get ready? So that professionally, that drew me to cybersecurity. And I just started learning more and more about it and realizing that there's a lot of depth, technical depth, operational depth to that topic. On the personal front, I've always been interested in cybersecurity type topics, specifically in the area of things like cryptography. And the earliest I remember was probably high school and like early college when it's the idea of public key encryption. I think that blew my mind. The whole idea that you can do something to a secret and it becomes irreversible except with this so-called key that is completely different from how you created an encryption. Like the asymmetry of it, the mathematical elegance of cryptography was very compelling. And so that got me more interested in just the mathematics behind it. I was never talented enough to know the math, but that became kind of the undercurrent of a lot of these interests.
That's really cool. So coming back to the NSA Codebreaker Challenge, I think the last I kept up with your posts was, I think you had achieved tasks 1 through 5. Is that still correct? And can you walk us through what each task entails?
Yeah, I can walk you through it. That is still unfortunately correct because I never cracked 6. That was too hard. Let's walk through the different tasks. And this, at least this past, the 2024 challenge, it's organized. There are different spikes in difficulty. And so the audience, if you do like medical school and you like go through pre-med, you might recognize this. You got like really, really hard course up front to kind of weed out the people who are not serious about it. And then it starts really easy, gets really hard, and then it kind of eases off and it gets really hard again. And so this year, the background is around these kind of so-called, nation state advanced persistent threats. And the story behind it is that it's, first you recognize that NSA recognized that there is something abnormal. So just like there's an anomaly of some sort. And actually, let me backtrack. There's a task 0 before everything starts. You basically have to register, sign your name, and you get a point just for doing that. And all right. So that's task 0. So task 1 is you get a spreadsheet, and your job this is a spreadsheet of transactions. So there's different the payer, the receiver, different dates when it happened, what is the description of that transaction, and so on. And your job is to find the one transaction that is abnormal. And that's a spreadsheet with, I don't know exact number, but thousands, maybe tens of thousands of records. And there is, each of these, think of it as kind of, it's automatically graded. So there's only one correct answer. Your correct answer is randomized, meaning that you can't just take someone else's answer and use it. But there is just one of those lines is abnormal. And every time you submit an answer, and if it's incorrect, there's a cooldown period, so you can't just brute force. Interestingly, and the NSA thought about brute forcing. So that's task 1. You're supposed to find the single record that's abnormal. And then it kind of goes up from there. Task 2 would be, there is an abnormal record. The team goes in and they dug around. They found this encrypted collection of files. They don't know what it is. They think it's relevant. And your job is to, quote unquote, figure out, recover as many files as possible from that record. And spoiler alert for those that want to try the NSA challenge. I'll go into a little bit of detail, but not too much. One of the tasks I did manage to finish. In this case, it happens to be a collection of snapshots from ZFS. So the ZFS is a file system. It's resilient in multiple ways, but because you just got binaries, it took some effort just to find out what's in it, that it actually is a collection of ZFS snapshots. But because they're not organized by date, they're not organized by any logical fashion, your job then becomes, well, how do I recover data from it? And then as you move on, you start realizing things like, well, it's a snapshot of a file system. So it documents all the things that can happen to it. So files can be created, it can be stored, but it could also be deleted like halfway through the snapshot. So in order to recover as many files as I can, I have to extract files at every point of that snapshot in chronological order. That's the only way to recover everything. So once you kind of slowly parse through, and again, your input is just a bunch of binary data in non-specific files. And so once you get to that point, you're ready to crack the task, because that's the crux of the task is just you need to get a SHA checksum for every file that comes out. And that's how they verify that you got it correct. So that's the task. Task 3 is actually where many people, so if you look at the statistics of people who finish each task, you get maybe X number of percent, 10, 20% of people drop off at each task. So task 3 is where 90% of people gets weeded out. It is the weed out task. It's a reverse engineering task. Reverse engineering tends to be the one that does it, because if you have a computer science background or data science background, unless you have very specifically an expertise in reverse engineering, it's probably completely new to you. So that's a problem. It was completely new to me. I've never done reverse engineering in the past. And so that one took me a while. I ended up having some conversation, kind of just, without doing spoilers, you're not allowed to directly collaborate in a team with somebody else, but just kind of like there is a Discord channel and, you can kind of high level discuss with people what to do with it. So and then with that, you also have the opportunity to use some tools to dig into the binary. So it turns out it's one of the more difficult programming languages to reverse engineer. It was written in Go, and Go or Golang, the way the binary is assembled is that a lot of the strings, so the plain text that's in the binary, is actually all aggregated and put towards one portion of the binary rather than like a typical C++. The strings would be embedded in the assembly code and kind of somewhere in the middle. So you can kind of figure out what the assembly code is doing in context. But in Golang, they're all like extracted and then referenced at portion of the binary. So that was really, really difficult. And eventually, once you dig in and you kind of try to figure out what's going on, you can identify that there is a test account in the binary that bypasses some of the security checks. But there's also other checks that checks whether you are using a test account to do it. So what you can do is you have to look at the cryptography used inside the binary. So we reverse it to assembly, maybe decompile it to C or Go, and then you can interpret the code, look at the cryptography, and then eventually you can recognize that there is a truncation that happens in the cryptography. And because the hash is truncated, it is possible to have a collision. And because it's possible to have a collision, you can find a username that has the same truncated hash as the test account. And if you find that username and you figure out the specific parameters around it, then you can potentially bypass the security without it triggering check that it was a test account. And by doing these series of tasks, you can then get through task 3. I think just based on kind of the community response, it is easily the most difficult task of the whole challenge. Except for me, I think task 6 is harder because that's the one I got stuck in. I eventually did get through 3, but that's the one that if you get through, once I got through it, I actually got a QR code from the NSA that, once you scan it, you will realize that it's a recruiting link where you can put an application for those that are interested. So that's kind of the bar that was set at, okay, maybe you know a few things about this field.
I take it you turned down the job?
I did not apply. Unfortunately, it was tempting. It feels like a badge of honor because just like so few people were able to get through it. And actually through even the end, like even January, the Discord channel still have people complaining about task 3. And I was always tempting, maybe just put in and see what happens. But no, I ended up not putting in an application for it.
Still a badge of honor though, right?
It is a badge of honor and it's satisfying. That's just like the first few tasks, but even in the early tasks, once you get through to a milestone, like you get it done, you submit it, and there's a few seconds of like that trepidation. It's like, did I get it right? And then when it finally, usually it says, no, you got it wrong. But when it finally turns green, that's an immense satisfaction. And once, I think this year there's interesting topics on top of that. So task 4 actually uses a large language model. So the NSA set up essentially a log of large language models. So they didn't actually give you a Llama or GPT or anything like that. But what your job is they have basically a server that has all the execution logs of an internal, quote unquote internal, in this fictional organization. They build an internal large language model and they capture all the logs of all their employees communicating with a large language model. The problem is what you're told is that a perpetrator has inserted malicious code into the large language model such that when it's asked to write code, it may try to slip something in there into the code to create a vulnerability. And so you have access to just this server. That's all they tell you. It's a server, and they don't tell you that, what the API is. They don't tell you how to communicate with it. You can ping it. Maybe that's where you start, but you have to figure out how to communicate with it. And eventually where you got to is you have to figure out how to extract in plain text all the logs that are relevant, or perhaps just all the logs. And then from all the logs, it can end up being like 200 pages of text. Of all the logs, you then have to figure out, well, what is the line that introduced the vulnerability that was generated by the large language model? And once you get all that correct, you get to the next task. So task 4 was a lot of fun because I think it's the most programming, like from a computer science and developer background, you probably would feel most at home in task 4 because you're just trying to figure out how to interact with the server and then processing text. So that's pretty cool. The part that makes it a little bit tricky is that what's logged into the server is not actually the user input, it's the user keystrokes. So if you've ever been in the Linux kernel and you know in the situation where when you hit the arrow keys or hit like a control key, it doesn't actually do the arrowing, or it adds some random gibberish onto the screen. That's because that random gibberish is actually the key code for your arrow keys and control. So those are the things that were captured. So what you pull out of a system is like, I think we ended up, in the chat after the competition is over, people started talking about how, boy, that developer that you had to extract, well, they're terrible typers because there's a lot of backspacing, and then the words will be typed, you'll have typographical error. It's obviously intentional because it's designed so that you can't just brute force your way into, you have to basically reverse engineer the keystrokes to get to what the actual output is, and then figure out what it is, the text that was generated. So that's the little twist into it. Again, I felt most at home with that task because it was more of a software development and a kind of general computer science kind of a task.
So that was task 4.
That was 4.
And then task 5?
For the 5th task is straight up cryptography. And I think for most people that end up finishing task 5, they would say that it's probably the most elegant task in the whole challenge this year. And the reason is because, so the story behind task 5 is that you now have a disk image of the extracted data. The disk image is an encrypted file system. And you have some chat logs. They're kind of like, AOL Instant Messenger chat logs and so on from various users. And they were copying and pasting to each other public keys. So not private key, they were exchanging public keys. And long story short, you realize that they're using custom cryptography to do the public key generation. And they were using custom cryptography for the encrypted file system. And once you start doing a little bit more digging by looking into the directory of the files that were actually viewable and given to you, you start realizing that the cryptography that they use was actually like published. They're like published in papers. And if you go and look up the actual cryptography that was used in the papers and you read through the papers, you will realize that there are some known vulnerabilities for those particular methods. It wasn't just one cryptographical method. There were 2 separate methods. And so it's kind of like if you imagine like playing a video game and you're trying to enter the store and you needed 2 keys. So you have to go to the left, finish the dungeon on the left side, get one half of a key, go to the other side, get the other half of a key. That's what this one is about. In order to actually decrypt the file system, you needed a key where half of it you would get by basically finding the vulnerability of one of the cryptographic methods, and then the other half you will have to read a different paper and learn a different method and then crack that one. And then between the 2 of them, you can then decrypt the file system and read what's in it. So that's task 5. Again, it's considered, felt to be very elegantly put together because of just the way that it was constructed, and it feels very intentional and well designed. Right now, I don't know what task 7 is because I never got there because they don't allow you to start until you finish the previous one. But I can tell you all about task 6 because I was on there for a whole month and I don't know what to do with it. It's a DNS. So you got to a point where you found out that this persistent threat is basically, it has managed to hack military vehicles, fictional military vehicles, and gotten these military vehicles to submit their coordinates, presumably US vehicles, right? Submit their coordinates to a remote server. Basically, it's like broadcasting where it is at all times. And in order to figure out how this whole thing works, that's your job, you got a core DNS. So it's a DNS server. It's a publicly available core DNS, but it's been modified in some way. You got a binary of the modified core DNS server, which is, by the way, written in Go. And this time it's stripped. So there's all the plain text have been stripped. If the folks, just kind of quick understanding of what stripping a binary means is basically a post-processing method after binary is compiled. They get rid of all the plain text references to it. So instead of meaningful, like URL for my backup files, like instead of meaningful function names and variable names, they get replaced with gibberish. And as well as many of the plain text. You can still get some plain text out of it, but it becomes really difficult to read it, which is exacerbated by the fact that in Go, they're all put toward one side of the binary and they're not in context. And also complicated by the fact that core DNS, because it's an actual thing, it's not just created for the challenge, it's an actual product. It's a large binary, maybe 100 megabytes or so, and you have the binary version of that to sort through. And then you have a second binary. A second binary is a microservice that presumably in the story is run on the vehicles that's sending the coordinates in a very specific way. And your job is to figure out the format of these URLs that it's sending to the DNS server. And so there are two binaries. They're both stripped. They're actually not both written in Go. Yeah, and that became the challenge. And it was very difficult. That's the one I got stuck on. So after the challenge is over, people are then allowed to talk about the challenges. And so over the next month or two, we would expect to see like walkthroughs and basically write-ups, pontifications around each one being publicly available. And I look forward to seeing those, how to get through this one. This is the other task where you have the biggest drop. So about 50% of everybody who got all the way through 5 get through 6 and beyond.
Interesting. And then it would be pretty funny if 7 is a super easy one, just because like, hey, you made it.
It's probably not as hard as 6 from what I can gather. There's something there that's pretty tricky.
Yeah. So I do have more questions about NSA Codebreaker Challenge and your interest in cybersecurity, but I'm actually going to go on a quick tangent here. So in doing this is obviously really cool stuff. I actually took some notes about some of these challenges. I would ask you more about them, but I'm curious, did you feel at any point with one of these tasks and the skills you acquired in the process or skills that you maybe revived, did you feel like any of it applied straight up to your daily life, whether inside work or outside work? Anything that was, made you have a aha moment?
I think so. And it's probably the meta of solving these tasks. So here's what I mean. If you're somebody who doesn't have a lot of like straight up book knowledge or industry knowledge on how to do these tasks properly, but someone has set a target, right? You have a very clear target for what you want to accomplish. It takes a bit of outside the box thinking. It takes a bit of persistence. It takes a bit of willing to just be wrong all the time. And I think some of that translates very well to, say, the hackathon challenge or from SIIM. It's a similar idea. And it actually translates well to life. Nowadays, in radiology informatics, imaging informatics in general, or even just imaging, the broader category of careers, there's fewer and fewer things that are just by the book, right? Like I'm a musculoskeletal radiologist, and even just like once you finish fellowship training, your knowledge starts deprecating. And there's no real structured way to gain that up-to-date knowledge. For instance, everyone who graduated fellowship similar time I did, none of us were ever trained on how to use AI, how AI is wrong. You have to figure out on your own. And it takes a lot of same skill set. Reading up is like, well, how do you get started? Well, just do it. Like, go look up what's out there, read about it. Maybe it doesn't make any sense when you read it the first time. Maybe it doesn't make any sense the first 10 times you do it. But at some point, it will make sense. And at some point, wake up the following morning, go to work, and see something that rings a bell that didn't seem like it was relevant before. And actually, I'll tell you, I'll also go on the tangent, Mahana. I have a bachelor's degree in computer science. I like dabbling in code, but I don't have a machine learning formal training background. How I got into machine learning was back in 2016 now. So 8 years ago, Microsoft put up a machine learning challenge for women's health. They posted, I think it's a subset of the data, but the source data was like 800,000 women from the then called Bill and Melinda Gates Foundation. In their philanthropy work, underserved countries, they collected women data. And the idea would be to do machine learning to predict healthcare risk, given some tabular data related to the patient. And I didn't have any machine learning background back then. And so I did almost exactly the same thing. You read up, can I just do like a basic equation like I would a linear regression, ANOVA? It was like kind of treat it like a research project. Turns out that didn't work very well because it worked very poorly on the patient-by-patient prediction basis. And then you start looking at, well, how do other people do this? What are some tools that are out there? I became familiarized with the Microsoft, then called Machine Learning Studio back in 2016. I started learning in how Bayesian networks work, probabilistic distributions. I started learning about, back then, it was really all about fully, like non-convolutional, just full generic kind of artificial neural networks and how they're constructed, and learn a few things about random forest algorithms, and then eventually figured out, maybe I'll figure out how to try each of these algorithms on the task, and then got to a point. So at the end of that challenge, I placed number 13. So I didn't make it onto the top 10, but I was on the leaderboard. And that was kind of, again, it's similar to the NSA challenge. It was a big satisfier in that, well, maybe I could figure this out after all, even though I started off with not knowing a whole lot. And yeah, so I think to kind of come back to your original question, is kind of about the meta, the persistence, and just willing to say, well, I'm just going to go and read some stuff about this and then give it a try.
So if I could maybe reiterate what I understood from you is a couple of things. When you're curious about something, don't be afraid to just jump both feet into it. And I think the other thing you described is something that we often talk about in the SIIM community, imposter syndrome, right? Fake it until you make it. I totally agree with you. That's the way to do it, is just jump. I sometimes joke with people because I have an undergrad in computer science. Well, it's actually my only degree. Don't tell anyone. But
nobody can tell. I'll tell you.
Yeah, indeed. This podcast is not public. I tell people that, we computer science people basically make our work look complicated by inventing all these weird acronyms to scare people away. And it's funny because you were talking about the challenges, like, everyone challenge 3, 90% of the people, drop. I remember similar things in computer science school. In my case, I think it was after a year or two, like at least a good 60% of the class drops. And year 2 during my days was when we started covering object-oriented programming, which sounds like a fancy, scary acronym, but the concept is very simple, in fact, very natural. But just some people can't wrap their head around it. And that fear factor, I think, is what holds people. So, being a go-getter, I think, makes a big difference in that regard.
Yeah, I couldn't agree more. And in some ways, this is also an advocacy, I guess, for unstructured learning. There's definitely a role for structured learning. Medical schools exist for a reason. Computer science programs exist for a reason. There are data science courses. SIIM offers them in SIIMU. There's a lot of value in those, but they shouldn't be the only way you learn. And there's, I would say, at least equal value in find a project and try it and be okay if you don't make it very far. Or in my case, I didn't finish the NSA challenge. I think it's probably the best learning experience I had all year. And I'm a very fortunate person who has a career, a job that offers a lot of learning opportunities. But I still think that this one thing I do outside of my job was the best opportunity for learning I had.
Yeah, absolutely. I'll add one more thing to what you're saying is when you talk to education experts, people who have formal training in education, one of the first things they talk about is that people are different modes of learners. In my own words, not their scientific words, basically it boils down to there are people who like to sit down in classrooms and be taught. They like didactic learning. But there are people who like learning by doing. And for me, that was one of the first things I learned very early on in my university career is I prefer to learn by doing. And it sounds like, something like the NSA challenge or that AI challenge that you tried back in the day was a similar thing. It's just jump and learn by doing.
Yeah.
Communicating with people online, trying things. And yeah, it sounds like with the NSA challenge, you were saying about, it's okay to be wrong in the process of figuring it out. In this case, you're going to be wrong most of the time until you finally crack the code, right?
100%. And, Mahan, you and I were talking about family before the recording started rolling. And so I'll give an analogy. Can you imagine teaching your child how to play baseball by starting with physics? Well, there's a 9-point, like the acceleration of gravity is this is why the ball falls down, but you have to, no, like here's a stick, here's a ball. We'll start with a lighter ball so it doesn't hurt. Hit it, and so this is how you throw a ball. And so I think, ironically, unstructured learning is perhaps in some ways more natural than structured curriculum. Nevertheless, to be at the absolute top of your field, you need both, right? Because structured curriculums are designed to fill in the gaps that you don't get by just doing projects. The project will give you a lot, the majority, I would say, of the real world experiences, but there's always going to be that little, the thing that unexpected, but is really important. And we stress that with medical education as well. And certainly with computer science, you'll run into the edge case that you wouldn't even think about if no one taught you to think about it. In cybersecurity, it would be something like SQL injection. Like you won't stumble yourself into figuring out SQL injection unless somebody told you or you read an article that describes how that works. And so that's an example. You definitely need a little bit of both.
Yeah, for sure. You mentioned family, and that was going to be one of my questions for you today. So I know you have a young family and obviously have a very busy professional life. You also are involved in a bunch of things, I guess, inside, outside work. I know you're involved in the ACR quality and AI initiatives. Recently, I saw a post about you writing a book about AI in healthcare. And that's just the stuff that I'm aware of. There's probably even more that I'm not aware of. How do you make time for all these things? And this is not just me, kind of poking into your life, but also like, what's your advice for people as far as, budgeting time and making time for all the things that do matter? And there's a lot of them, of course.
Yeah. I wish I know the answer. I wish I know the right answer. I'll tell you my answer. I think it really helps to have the right partner, right? So I owe a lot of the flexibility to having an incredible spouse. I also have, since my family started, I learned to say no to certain things. For instance, and I'll say it on the podcast I am on some of the task forces and subcommittees for SIIM, but it's been really challenging for me to travel for the board meetings or for certain committee meetings. And I say no. And it used to be, I get that guilt, like strong guilt of saying, I feel terrible. Over time, I think it's part of growing up and becoming mature and say, no, actually, I am so proud to be able to work, to spend time with SIIM in an organization that understands, okay, we'll make some of this remote available. We can make this flexible for you. And actually I also volunteer for RSNA and American College of Radiology. And that has become a theme that, hey, we understand that this flexibility is important for people. And so being able to work in a environment that understands those different demands is really helpful. From a more personal standpoint, I think it comes down to time management as well. To give an example, I think the NSA Codebreaker challenge, obviously you only do it during your personal time. Well, there is actually a period of time after my kids go to sleep and my spouse wants to spend some time watching the latest show that maybe I don't have as much of an interest in. She needs her alone time. Okay, well, that's my alone time. I will do some NSA Codebreaker challenge work. And so that's how you can kind of fit some of this in. And yeah, ultimately it's about finding out what matters to you and carving out time to do it. The last part I'll share, again, this is my answer. It doesn't have to be you or anyone's answer. Is kind of find overlaps in those areas. So I'll give you one example. About a year or 2 years ago, I found out that my older son, his name is Connor, he's really, really into STEM, like to a point where he's asked, today now at 7 years old, he's asking me about electromagnetic radiation and questions I don't know the answers to. But even a few years ago, when I realized that he gravitated towards just engineering and logic strongly, I started showing him teachable machines that's a Google free product. It's basically a mini like web-based AI model creator. And I show it to him and we built little models for soccer ball or balls versus things that are not balls. And then we talk about concepts like, well, you can't just show it a book and say that's not a ball. You can't just have balls and books and then call that category not balls. You have to have a variety of things, and including things that are round, but that are not balls. So we talk about false positive, false negative, how you trick the robot into making decisions that are wrong, and then figuring out then how do you teach the robot so it no longer makes those mistakes. And finding those overlaps, and that just became like I have vivid memories of doing that with my 5-year-old, a few years back, and some of my most fond memories. And he still remembers every once in a while he would ask, hey, can we make another AI robot thing? Then we would do that. So yeah, finding overlaps can help too, to kind of make sure that you're quote unquote checking off multiple boxes, right? Family time, quality time with your child, as well as working on something you're interested in.
That's an awesome story. Thank you for sharing. It is pretty cool. And it's actually super cool that he's that interested in STEM at a very early age, I would say, at this point, right? I don't think they would have done that much science in school yet. They're probably still exploring what seems like primitive topics comparing to where he's at.
Yeah, well, I think some of it has to do with just he finds books lying around in the house that I read, and then he picks them up. And he's like, I don't know this word. So Dad, explain this thing that's on this, postgraduate textbook. It started that way, but then and both kids have they're different, and that's the beautiful part about it. My younger son actually, he's kind of interested in science, but he gravitates way more towards music and arts, and we'll see how he differentiates over time. That's the beauty of it, just like discovering those things and figuring out, well, how do you foster those areas without making it seem like I don't want to just like make my son into me. How do I encourage him to develop it if he's really interested in himself?
Yeah, absolutely. And nurturing that is, as a parent, not easy, but also so rewarding when you see them finding their passions and feeling so good about it.
Yeah.
So, Howard, I was just looking at the time. I can't believe where the time went. This conversation is just so much fun. That being said, I'm not done with my questions. I still have plenty of questions, but I'll try and keep it short. One of the things you touched on was, of course, your volunteer work with SIIM, among which I happen to know is, of course, you are the chair of the Security Subcommittee. And I know your subcommittee has been very passionate about educating SIIM members about cybersecurity. I know you guys have been involved in putting on webinars. You were involved in putting on some of the educational programming at the annual meeting last year, which, by the way, I was super enthusiastic about for a number of reasons. Because number one, as much as I love AI as everybody else, I get annoyed when I feel like AI is sucking the air out of everything else. So that was a breath of fresh air to see, other topics coming to the surface at the last annual meeting. But of course, cybersecurity is extremely important. It's easy for some people to be like an ostrich and stick their hand in the sand, like, hey, if I don't see it, it won't hurt me. But it's something that it's an uncomfortable topic, but we need to talk about it. So anyway, that was a super long-winded question. Tell us a little bit more about the Security Subcommittee and all the work you guys are doing.
Yeah, I'm glad you asked. So the Security Subcommittee does a lot of work mainly in educating the SIIM community and those outside. So we do a lot of webinar. We make sure that there is a percentage of the SIIM annual meeting dedicated to promoting security and awareness, not just in the science of security or the technicalities of security, but also in practical. So operational recovery, operational continuity, and we help coordinate that balance. The other things that the Security Subcommittee is writing and contributing to the literature. So SIIM is writing a white paper with the American College of Radiology on cybersecurity in imaging. So the Security Subcommittee takes charge in that effort as well. Yeah, and finally, there's a lot of effort just throughout SIIM and beyond on understanding what is it that we can do, right? So cybersecurity, we know that security is a business of everybody, although we may not feel that on the day-to-day basis because maybe it's just a form you have to submit at work to get a software approved, but they don't feel that until an event happens. So the SIIM Security Subcommittee gives a way to kind of organize around that. So the group comes up with kind of out-of-box ideas about webinars and seminars to help highlight those topics.
Very cool. So it sounds like we should be looking forward to some portion of the next annual meeting also dedicated to security then.
Yes, keep your eyes peeled. But even before that, there will be some webinars coming up, probably in May or June of this year. That's going to be security focused. And then that will lead us right into the annual meeting.
Very nice. Thank you. In the process of this conversation, you talked about kind of dipping your toes into different things that, get your attention. You mentioned the AI, I think it was challenge from Microsoft. Of course, the NSA Codebreaker challenge. Is this something you'd recommend to other imaging informatics professionals to get their feet wet into topics like AI security, et cetera? And generally speaking, whether you recommend this or recommend something else, where is the good starting point for people to find out about these things and get rolling?
Yeah, I would recommend 100% for folks that are, I'll say that those are eligible because SIIM is an international community. The NSA Codebreaker Challenge is available for Americans that have a university-based email address. That being said, the nature of the task, the project-based or problem-based learning is, I couldn't recommend more for folks that are interested in getting your feet wet. For those that are interested in AI, for instance, Kaggle is a great place to start. The RSNA, actually, I am now promoting a different organization's work, but I am also the lead for the 2026 AI Challenge for RSNA. It's going to be on musculoskeletal radiology. But every year there's a challenge, and that's a place to start because they're created by people who work every day with AI in real life and then build a competition for those to help people get started, understanding the most important things about building a model, validating a model, and so on. I would say that other resources to get started, take a look at SIIM, and the webinars are coming out, and listen to SIIMcast. I think these are probably the lowest hanging fruit because you kind of need zero background, right, to get engaged. In fact, thanks for reminding me. I have a colleague, an old friend, that was just transitioning into a position that puts them in kind of an IT related role. And they say, well, are there any resources out there? How do I get started? I bought the Practical Imaging Informatics book. I don't know that I can get through it. Like, it's a little deep for me. So how do I get started? And I said, listen to SIIMcast. And, he started. He actually went as far as telling me, Howard, the first episode is not available. The earliest was in 2019 or whatever on Apple Podcast. And so I said, well, you want to start from episode 1. Okay, that's incredible. And so he started from the earliest he could find, and he's working his way through all the subsequent episodes.
It's an awesome story. I'm pretty sure the archive is still available, but I will point out that's actually a similar story to how I started. I was actually a groupie. So the SIIMcast podcast was actually started by Prasanth and Arjun, and they were at it for a few years. And I was a fan because at the time I did some traveling, and that was a fun, easy thing for me to listen to, learning new things. And it's a nice mixture with SIIMcast. There's some episodes where we learn stuff. There are episodes where we get people to just tell their stories. So it's a nice mixture of, storytelling and education. But yeah, I was a groupie. Every time I saw Arjun and Prasanth at one of the annual conferences, I walk up to them like, I'm such a fan of what you guys do. And then after a couple of years, they asked me, why don't you join us? And I'm like, oh yeah, that's a good point. Why don't I join you? And here we are.
That's awesome. I love it.
It is indeed. So Howard, this has been an awesome conversation. We're coming up to the end of our time here. Any other closing thoughts, anything else you wanted to add? And of course, I want to thank you so much for your time. This has been an awesome conversation.
Oh, thank you for having me here. It's great to talk a bit about things I'm passionate in and being able to catch up with you too, Mohammed. I would say for the audience, yeah, definitely check out the NSA Codebreaker Challenge if you are interested and can participate in the upcoming one, but also the current year is still available. The challenge is still out there. And so this is the fun part, the fun period where you have both the challenge available and the walkthrough, a solution that is being written by the community. And so to kind of, again, like if you're looking for an opportunity to get your feet wet in the space, this is the best time. And outside of that, keep your eyes peeled for the security subcommittee. We have some video content that's coming out. We have webinars coming up, and look out for us in the annual conference.
Wonderful. Thank you so much, Howard. I appreciate your time here today.
SIIMcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at @SIIM_tweets. Thank you to our listeners for your continued support.